how did we get to the situation today where fossil fuels are entrenched in global industrial food systems? Where would you start the story?
I'd start the story in 1918.
I can't remember the exact year, the 1880s.
I think it's going to be Christopher Columbus. Let's start right at the beginning.
But when we talk about mechanization, we usually start that story around the 1830s.
And that's when they started replacing horses with fossil-fueled tractors.
The story of the rise of fossil fuels is the story of replacement. Replacing human labor with fossil-fueled machines. Replacing natural substances that made up fertilizers and pesticides with fossil-fueled agrochemicals. Replacing time spent in our kitchen with new types of food processing. Replacing local seasonal foods with, I think avocados are in season somewhere. Welcome back to Fuel to Fork, where we expose the fossil fuels in our food and imagine a future without them. This series is powered by Table, IPES-Food, the International Panel of Experts on Sustainable Food Systems, and the Global Alliance for the Future of Food. I'm your guide, Matthew Kessler. Episode 2, The Rise of Fossil Fuels in Our Food System. How did we get here, and what are some of the impacts on health, biodiversity, and foods from the ocean? When I asked the people I was interviewing for this series, where should we start this story with fossil fuels in food? The Haber-Bosch process probably came up the most. This process invented a way to literally take nitrogen from the air and turn it into a fertilizer. This was considered a scientific impossibility, and now it accounts for roughly half of the world's fertilizer production. 120 million tons a year of nitrogen fertilizer. It's a story about human ingenuity, feeding a growing global population, and unintended consequences. We'll get there a bit later, but we're going to start our story in the previous century with a different fertilizer, guano, the droppings of bats and seabirds. This stuff is packed with the nutrients that are good for farming: nitrogen, phosphorus, and potassium.
Fertilizers used to be more natural substances, right? Wastes and bird dung.
That's Jennifer Clapp, professor and Canada Research Chair at the University of Waterloo.
And I'm also a member of IPES-Food, the International Panel of Experts on Sustainable Food Systems.
From 1840 to 1870, guano wasn't just any farm input. It was the world's top traded fertilizer and the most popular agricultural product in the United States. Two key factors made this possible. First, there was the observation that applying guano to the soil significantly improved plant growth. Second, there was a shift in scientific thinking about how farms should be managed.
The need for fertilizer as an amendment to soil, really this idea goes back to the 1840s where, when Justus von Liebig wrote about the importance of nitrogen, phosphorus, and potassium as important nutrients for plants.
Von Liebig was a German scientist with a deep passion for chemistry. He revolutionized laboratory-based science education, though that's a story for another time. For our purposes, his key contributions was that he
raised awareness of these chemical, nutrients that need to go into soil for better plant growth. And this is what gave rise, really, to the international guano trade. This work that von Liebig did in the 1840s was, in a way, it kind of like scientificized, if that's a word. It turned this kind of thinking about soil fertility into a scientific formula. And this then freed people from thinking about it the way they used to think about it, which was referred to as the humus theory. And that was basically thinking that you need organic matter in the soil to create the kind of fertility. So farmers used to use local waste. It could be animal waste, human waste. It was usually waste that was produced very nearby to where the farm fields were.
Of course, farmers around the world already knew that using animal manures, byproducts, and waste products on their farm would lead to better harvests. Blood and bone meal, fish scraps, wood ashes, even human waste. Now they wanted access to guano, which had this fantastic balance of nutrients and was especially rich in nitrogen, the most foundational nutrient for crop growth. But where did this fascination with guano start? In 1802, German naturalist and explorer Alexander von Humboldt was 3 years into his expedition across Latin America and encountered something that would change the world. He observed Peruvian workers unloading sacks of guano from the Chincha Islands.
And the Chincha Islands off Peru was very rich in guano. Going back hundreds and hundreds of years, there was awareness that this particular bird dung was rich in nitrates.
Fascinated, Humboldt took a sample back to Europe, where they also observed its potential as a fertilizer. This would become the catalyst for a massive and ultimately destructive international frenzy, the mid-19th century guano boom. Soon, European and North American nations began extracting guano from Peru's coastal islands on an industrial scale, changing the course of global agriculture. This was based on a highly lucrative, yet deeply exploitative trade.
It took thousands of years for that bird dung to basically make a nice deep pile,
How deep? In some cases, these piles were documented to be 60 meters, or nearly 200 feet deep.
That was then subsequently mined. And so, it was mined really quickly when you think about how long it took to develop it. And it's the same principle when we talk about fossil fuels. Millions of years for these fuels to basically form under the soil. And then we, once they're gone, they're gone.
Another similarity with fossil fuels is that extracting these inputs exploited both natural resources and human labor.
That trade was deeply problematic. It was using basically slave labor and indentured labor coming from Asia, terrible working conditions, backbreaking work, people breathing in horrible fumes, and many, many workers fell ill. Others committed suicide. It was like a horrible experience. But also within 30 or 40 years, the entire guano on the Chincha Islands was, it was gone. It was basically exhausted.
So the search continued for other fertilizers across South America, and a significant nitrate trade emerged, with mining operations in Peru, Bolivia, and Chile. But this operation wasn't at the same scale of guano.
These were exhaustible natural resources, and they also were subject to disruption in trade, especially because of, politics, geopolitics, and war. And so there was a huge desire in places, especially in Europe, to come up with a way to synthesize nitrogen, because we know it's in the atmosphere. That was like the holy grail, to figure out how to do that.
Why was it so important to figure this out? Let's consider the conditions in the 1800s. There was a growing and urbanizing population in the United States and Western Europe. This removed people further and further from farm fields. At the same time, there was a shift in how Western scientists thought was the best way to manage soils. From the humus theory of adding organic matter to the soil, to treating the soil as a patient that needs to be prescribed a specific set of nutrients.
And I would say that in the 1840s and 50s, the question of soil fertility, it was the top number one ecological problem that people were talking about. And suddenly, when we had nitrogen synthesis by the early 1900s, people just stopped thinking about it. And it wasn't like, the conversation everybody was having on a daily basis was no longer about soil fertility, because we were basically creating this, to use a pun, we were fixing this problem with nitrogen.
Coming up, how we fixed the problem with nitrogen and created a new one. I like the guano story. It shows that there's a long history of exploiting resources from outside of the farm. But you could start the story even earlier, Food has traveled and been traded for thousands of years. Basically, as soon as humans found ways to preserve foods. And exploitation also has a much longer history. We could have started with the transatlantic slave trade or the Egyptian Empire. Next, we'll talk about the invention of synthetic nitrogen fertilizer. A few things happened all at the same time. Around the world, there was a major increase in food or calorie availability. Many farmers became locked in to a particular way of farming, and it caused some devastating environmental problems. So let's go back to nitrogen fertilizer and see how it all started. Because in this origin story, there's some clues as to why the industrial food system looks the way it does today.
And Europe was sort of where we saw this rise of these kind of like intensive chemical industries that were emerging, BASF and Bayer.
Jennifer Clapp again, setting the scene in the early 1900s.
One of the first processes that was actually developed was in Norway. This is nitrogen synthesis, was called the Birkeland-Eyde process. And that was named for Christian Birkeland and Sam Eyde, who basically realized they had to create this reaction with the atmospheric nitrogen, and they reacted it, in this instance, with oxygen using hydropower energy from waterfalls. And this is actually the origins of the firm today, the big firm, Yara, the fertilizer company.
Norwegian physicist Christian Birkeland and engineer Sam Eyde established Norsk Hydro, which eventually became Yara, one of the world's biggest fertilizer producers. Today, Yara brings in more than $15 billion in revenue each year. But going back to 1903, they were actually the first ones to make a chemical fertilizer derived from atmospheric nitrogen.
Really around 1910, when we saw the sort of early origins of what we call the Haber-Bosch process of nitrogen synthesis, which is a little bit, different chemical process. And this process of nitrogen synthesis was using natural gas to reach really high temperatures to react with hydrogen, with the atmospheric nitrogen, to create ammonia. German chemist Fritz Haber came up with this process, and then it was purchased by BASF, the chemical company, which put Carl Bosch in charge of figuring out how to make this commercially within the firm. And so this became known as the Haber-Bosch process. What's really interesting to me anyway is that while we had these two early processes to synthesize nitrogen, one using a renewable energy source of water, hydropower, and the other using natural gas, it's interesting to me that when you read all of these sort of books on the history and chemistry of nitrogen synthesis, they say, well, the Haber-Bosch process became the dominant one because it was more efficient. And it raises questions for me about efficient for whom and et cetera, because you might think from an ecological perspective, it's more efficient to use hydropower.
Okay, so that's some backstory. Now I'm trying to think of how can I stress enough how much this fertilizer changed our relationship that we have with food and even with this planet, and completely divided people on whether this is a net positive or negative. For a living, I speak with different experts about the future of food. And for me, it can be a revealing question to ask them, what do you think of Haber-Bosch? Some are really quick to point out that across the 20th century, nitrogen fertilizer helped create enough food to feed an additional 3.5 to 4 billion people. While that's true, much of this additional output from cheap fertilizers and subsidies has been used for livestock feed. 1/3 of global cropland is dedicated for this use, making possible the industrial animal production system we have today. Meanwhile, others see nitrogen fertilizer as a driving force for shifting us from a farming system that had to be really clever about cycling most of its nutrients from the farm to a system dependent on companies for synthetic fertilizers made from fossil agrochemicals.
I mean, none of it was bad or evil.
Pat Mooney, co-founder of the Etc. Group and member of IPES-Food.
in the sense that development of synthetic fertilizers solved a major problem of a kind, which is that guano in the Pacific had been mined very heavily, and there was a great demand for more fertilizers. You could argue that we shouldn't have had a demand for more fertilizers. There should have been other forms of agriculture that wouldn't have required the mining of the soil in the way that our industrial system has been mining it. But still, the need was there, and it was, I don't think anybody would have seen it as a major problem.
The problems arose from overuse, from an addiction to nitrogen fertilizers. This fertilizer helped bring about a new way of farming that reshaped entire landscapes, ecosystems. And even though this sounds extreme, nitrogen fertilizer changed the way nutrients flow or cycle throughout the planet. And it certainly changed entire farming systems. Let's unpack how this plays out, where we first look at what it was like on farms in the central prairies of Canada 100 years ago.
I grew up on a farm and grew up spending a lot of time on my grandparents' farm.
Darren Qualman, Director of Climate Crisis Policy and Action with the National Farmers Union in Canada.
And when I think of my grandparents' farm, when they started farming in the early 20th century, virtually everything that went into farming came out of farming. They produced their own energy supplies. The fodder and grain for the horses came from the local fields. They produced their own fertility. They cycled fertility locally through manure and crop residues, etc. And they produced their own solutions to weed problems, etc. So if you run time forward from there over the last 100 years, in a number of steps, we slowly replaced those on-farm biological sources of energy and solutions with fossil fuel-derived replacements.
Darren would start the fossil fuel story just over 100 years ago in 1918.
That's the year following the First World War. There was industrial capacity. They learned how to make machines in large quantities. And that's when they started replacing horses with fossil-fueled tractors. And that was the first place in the agricultural system where they started injecting fossil fuels. So instead of the farms being fueled from their own landscapes, they were then fueled by distant fossil fuels. Fast forward to post-World War II, a real increase in petroleum-based chemicals, herbicides, pesticides, etc. And key is really to understand that the ever-increasing output of food energy coming out of our farms is a direct function of the ever-increasing inputs of fossil fuel energy going into our farms. We take natural gas, turn it into nitrogen fertilizer, inject it into the system, and that pushes a whole bunch of extra food out the other end.
In short, the more you put in, the more you get out. But there's only so much that a system can handle.
We have gone so far in terms of the nitrogen fertilizer addiction. The people that do work around planetary boundaries and the safe operating space for planet Earth, they tell us that we've tripled the tonnage of nitrogen that's flowing through terrestrial biospheres. We've tripled the amount of nitrogen that flows through the land compared to the pre-industrial period. And we're far, far beyond the safe operating space for planet Earth when it comes to that nitrogen flow. So we really have to figure out how to produce sustainable food systems and enough food for everybody while dialing back those nitrogen flows that are far outside of planetary limits and causing very visible problems like dead zones in oceans where the rivers move some of that nitrogen into the ocean.
So not only is this fertilizer heavy on the fossil fuel front, it's also polluting. Dead zones are actually as horrible as they sound. This is where excess fossil nitrogen fertilizers run off of farm fields and into surrounding streams and rivers and flow out into larger bodies of water. All these extra nutrients in the water triggers these algal blooms. So when these algae die and decompose, they consume oxygen. And when all that oxygen is sucked out of these aquatic ecosystems, other marine life can't live. If you collect all the dead zones across the planet, they make up a body larger than the whole of the United Kingdom. These dead zones also contaminate surrounding drinking water, and they've been linked to people experiencing respiratory issues, skin rashes, and gastrointestinal problems. So part of this story is it's created an addiction to these fertilizers. And you don't need to be a farmer to realize how that might make sense. You have fertilizers, you apply them to your fields, and your crops grow bigger, at least in the short term. That's a pretty easy sell. But it's not so simple. It's not just a synthetic fertilizer that you one time add to your system. This is where we transition from meeting all your farm's needs with what you could access locally into a more industrial input-dependent farming system. Jennifer Clapp describes how the rise of tractors and mechanization, paired with the rise of agrochemical fertilizers and pesticides, made for a complete transformation.
Basically, it allowed farmers to farm larger and larger tracts of land, which then kind of demanded more of these other inputs. Because once you were farming a large tract of land, you were then typically growing crops in a monoculture fashion. This made them more susceptible to pests, and it also exhausted the soil more efficiently because plowing was very disruptive to the soil, and then it led to a need for more fertilizers to be added to the soil. So these three inputs are deeply connected to each other in terms of their, locking in of the suite of technologies.
It's important to know how we got here. Understanding that is helpful for knowing exactly how to get us out of this mess. Another way to explain the dominant fossil-fueled food system is to look at the industries and the profit models maintaining it. Jennifer Clapp has tracked the history of how a few industrial titans that respectively run the fertilizer, pesticide, and farm machinery sectors shape the future of food. A handful of firms have accumulated enormous power in our food system. They use this power to lock in farmers and our food into modes of production that rely on fossil fuels and to lobby policymakers to protect that status. Companies like Nutrien and Yara, who manufacture fertilizers, Syngenta, Bayer, BASF, and Corteva, who produce pesticides, and John Deere, Kubota, and CNH Industrial, manufacturers of farm machinery. Jennifer says that they exercise their power in three key ways: market power, technology power, and political power. First, market power.
Firms that can control different aspects of the market, different parts of supply and demand, they basically can generate excess profits because they can control supply and demand in a way that allows them to raise prices and reap those higher profits. And this is common when you have high degrees of concentration in the sector, which we have today across all of these inputs.
For a few recent examples of this, fertilizer companies had raked in enormous profits during the pandemic and the Russian invasion of Ukraine. If the argument is that supply chains were disrupted, so prices had to be higher, that doesn't explain why they profited so much more during this time. In 2022, agribusinesses were able to hike fertilizer prices and secure profits 500% above 2020 levels. Second, you have technology power.
Basically, because there's just a few companies dominating the market, they really are able to shape technological developments in a way that gives them this kind of role of gatekeeper of what technologies end up being mass marketed to farmers. They're picking the technologies that make them the most money.
And last, you have political power.
And they do this through lobbying and other forms of influence like funding, research studies.
So through these three kinds of power, market, technology, and political power, these firms have a big influence on the way that industrial farming looks today. So like I said earlier, these are some of the ways you can understand how we got here. But the effects of a fossil fuel-driven food system aren't felt the same everywhere. In the final part of this episode, we're going to explore how people in regions are impacted differently around the world. We'll take a closer look at farm workers, biodiversity, and the oceans.
My name's Navina Khanna, and I am the Executive Director of the IPES-Food Alliance. HEAL stands for Health, Environment, Agriculture, and Labor.
HEAL is a national alliance of organizations across the United States. Navina Khanna talks about the social and health impacts on farm workers and laborers, both in where her family is from and where she lives now.
I've been just thinking about the region that my family is from in Punjab, right, which was the experimental birthplace of the Green Revolution, where the first chemical pesticides and fertilizers were used, and they were used to, quote unquote, save people from a famine and to boost yields.
The Green Revolution, spanning from the 1950s to the late 1960s, involved advancements in agriculture technology that significantly boosted food production in some countries. Farmers were introduced to patented high-yielding crop varieties to replace the seeds and varieties that were grown locally. To achieve these high yields, farmers had to buy expensive inputs like synthetic fertilizers, pesticides, and install costly irrigation systems.
Punjab is named for its 5 rivers, right? It's considered the agricultural breadbasket of that region. Been known for really fertile soil, really rich, fertile brown soil. And most people in Punjab historically identify it as agricultural people. And so in the 1930s, post the advent of the chemical pesticides and fertilizers, a lot of which we saw come up post-World War II, people in Punjab were given these fertilizers, pesticide seeds to use. And what that meant was an increased yield in that moment. And what it meant was people no longer using the practices that they had used to maintain healthy soils, agroecological practices, closed loop systems. And over time, what's that meant is that the soil is completely depleted there. The water is actually poisonous there. The rates of cancer that people are experiencing in Punjab are skyrocketing to the point that they call the train that takes people to the nearest hospital the cancer train, right? That's what we see in Punjab. And that mirrors very much what we see in a place like California, where I live, right? We're in the Central Valley. There's huge amounts of those same chemical pesticides and fertilizers being used. There's, if we're talking about just general emissions, there's these mega dairies in the Central Valley. And similarly, we see people lacking access to clean drinking water. We see super high, cancer rates in the Central Valley. We're seeing all of the same impacts on the farm working and rural communities in that area as you see in a place like Punjab.
Next, we talk about biodiversity with Pat Mooney, who is now retired after nearly 6 decades of working around food, biodiversity, and human rights issues. He co-founded the Etc. Group to bring awareness to and to protect agricultural seed diversity.
Well, certainly there's a Green Revolution.
Yeah.
Norman Borlaug, when he developed the semi-dwarf varieties in wheat and then eventually in maize and rice, when he developed those, he saw it as a short-term solution. He didn't see it as a long-term solution. It was something to be done immediately to solve an immediate concern in Asia, not in Latin America, not in Africa, but in Asia, to address the food crisis that was there.
I was excited to speak to Pat to help understand what's really difficult to put numbers to, which is how has biodiversity declined on farms over time? And how's that connected to the rise of a fossil fuel-driven food system? I first asked Pat, how genetically uniform is the food system today?
Well, it's incredibly uniform. I don't think we've even still fully understood how uniform it really is. When I first got into this work in the 1970s, my concern was about the genetic uniformity of plant varieties. So it was a genetic uniformity, that there was only a handful of wheats and rices and maize that were being grown in most parts of the world, the semi-dwarf types.
Farmers across the world were growing thousands of different varieties of rice, maize, or wheat. We're not talking about different crops, just different genetics of the same plant. Now these were being discarded in favor of a handful of high-yielding varieties.
We're in a world now where we have politely 12 crops that make up almost everything we eat, really 3 crops that make up about half of everything we eat, the wheat, rice, and maize. And you add on potatoes and you're up higher again.
So 12 plants: maize, rice, wheat, sugarcane, soybeans, potatoes, palm oil, cassava, sorghum, millet, groundnut, and sweet potatoes. And 5 animals: chicken, cattle, pigs, sheep, and goats. Make up around 3/4 of our diet. Meanwhile, there are almost 7,000 different domesticated crops that aren't being used, at least not commercially.
And that's tragic. The loss of species, the loss of genetic diversity.
So this is tragic if you think about the fact that when each plant variety goes extinct or becomes endangered, we lose not only biodiversity, but our future resilience to weather extremes. Think about how local varieties have adapted over time to different regional ecosystems. They've been able to thrive without the reliance on fossil fuel inputs. And we lose our cultural connection with these plants.
Then beyond that, we didn't recognize, not only starting to recognize, that we've created a microbial desert as well. The food desert that we really have is the one in our gut. The development of ultra-processed foods and the narrowness of the food system, that we've pretty well wiped out the genetic diversity in our own guts, the species diversity in our guts. The implications of that in terms of human nutrition, in terms of long-term health, in terms of even mental health, are again just being explored now. So we've had those 3 sort of erosions or destructions or wipeouts of our food system: genetics in the field, the pastures, and the microbiome.
Last but not least, we take a deep dive into the oceans.
Yeah, I started right from my grandfather. He was somebody who was very conscious of nature. He knew plants that could cure people. So he was a pharmacist in his own way, right? And he would tell us, when you walk on earth, walk as if it feels pain. I am Rashid Smaila. I'm a professor at the University of British Columbia. I'm also a Canada researcher in interdisciplinary oceans and fisheries economics.
Can you talk a little bit about what are the connections between fossil fuels and the food that we get from the water?
Yeah, lots of connections, really. Yeah. So in the first place, we use fishing vessels to catch fish, right? So the more you overfish, that means the more you use fuels, more than you should, right? And if you go far off and you fish because you've depleted the coast, like increasingly we're going into the high seas, you're going to go out in the open ocean, search for fish, and that needs a lot of energy.
Blue foods are the foods we get from aquatic sources, like fish, seaweed, shellfish, and they're made up of 2 components.
So you have the wild, which is what I just talked about. You also have fish farming, aquaculture, like salmon and shrimps, they need to be fed with fish meal and oil, and that demands a lot of energy. First, you have to catch the wild fish, and then you ground it, and all this need energy. So that is another channel, right? The third one is the fish value chain. In some cases, fish is caught, say in Alaska, polar. It is shipped to China to be processed and then shipped back to North America, pumping CO2, transporting it back and forth. So there are so many ways. And the gear we use to fish, if you use bottom trawlers, you are going to use more energy and therefore pump out CO2 more than other gears, and so on and so forth. So there are many ways that blue foods are connected to fossil fuels.
There's a lot to unpack here. First, you heard that right. Fish can be caught in Alaska, shipped to China for processing, and sold all the way back to North America. This makes no sense if you consider the transportation fuels and the emissions it causes, but it is a more cost-effective solution for companies to do this. And Rashid mentioned bottom trawlers. What are those exactly?
Some have actually described it as clear cutting. It's like going in with a big bulldozer and just knocking things down. You go to the seafloor and start just looking for what you want without due consideration to the complicated ecosystem that is there, right? So trawlers use large, heavy nets kept open by doors, weighing as much as several tons each. Many of them drag across the large areas of the seafloor to catch fish that live on or near the ocean floor.
How different is the landscape and the culture around fishing and the relationship with nature? How different is it now to when it was when you were growing up?
Oh my God, it's changed a lot, especially the fish. You know, you go to the coast of West Africa, and people will tell you, and you feel it, the size of the fish is shrunk. The different types of fish they used to catch are all gone, right? They tell me, look, Rashid, a few decades or a few years ago, we go out in half a day, we fill our boat. Now we'll go for a week and we can get half of our boat. And plastic wasn't a problem then, right? I mean, when I was growing up in West Africa again, we use banana leaves and corn leaves to wrap our food. Now you go there, your heart will jump out of your body. You see plastic everywhere. Half of it buried in the ground, half of it sticking up, very ugly, and they end up in the ocean, messing up the ocean and poisoning the fish and therefore us. So there's been a huge, big changes since I was a kid.
There's also the impacts of climate change on the sea, which is driving ocean acidification. As the seas absorb excess carbon dioxide from the atmosphere, they disrupt marine ecosystems. This rising acidity weakens coral reefs, threatens shellfish populations, and destabilizes the entire food chain. And you've documented some of these changes to the fish populations, to the size, to the amount of species that are thriving across different seas.
I have this beautiful map. If I had a slide, I will show you. If it was where we estimated, I call myself an interdisciplinary oceans and fisheries economist because I work together with ecologists, with mathematicians, with lawyers, because we all believe that. My collaborators, we all believe that no single discipline can do this. Together, we have mapped out the state of the fisheries in Northwest Africa. So we color it, The more green it is, that means there's more fish in the ocean, and then it becomes red. If you do that decade by decade, from 1950, you will be blown away. There's virtually no green color anymore. The fish are gone scientifically. So these are real data and model estimates of what is in there. And this happens throughout the world, There is an estimate, half of the fish stocks are overfished. And this is only the commercial, the things that we know. All the bycatch species are not even counted. So it's far more than half. So really, there's been big changes scientifically and otherwise.
How do we get to the state of the oceans being like this? It's a similar story to what we've heard about on land. Population growth and rising incomes increase demand, and technological innovation has increased supply.
When humans started fishing with harpoons, and then with your line and hook and so on, this has now become massive industrial enterprises. They can scoop the fish people used to take in a year in just a few days, right? So that technology.
Add in massive subsidies to the fishing sector to go find and harvest more fish.
Fish is not something you can conjure. It's nature. You have to take care of it, nurture it, take it carefully. We sap it out and then we give subsidies, taxpayer money, for them to go further and deeper. So the fish has no place to hide. That is also a factor. So a combination of many things. And then you have climate change. Oh my God. Climate change, we're pumping CO2. The fishing sector is part of it. And that is leading to ocean warming, acidification. You're having deoxygenation, less oxygen in the ocean. And we know that oxygen is life. So you have all these things coming, multiple stresses on the ocean and the fish, and all this is leading us to turning the green into the danger zone.
Does the food system on land and water feel hopeful or bleak to you right now? We've heard about human ingenuity in action, technological advances, new solutions to feed a growing global population. But in the process, our industrial food system has become completely dependent on fossil fuels for its energy and for synthetic fertilizers and pesticides. This dependence has dramatically changed how we farm and what we eat today. We've also heard a story about the ripple effect, about some of the broader impacts of fossil fuel-driven food systems on oceans, on biodiversity, on human health, on how nutrients flow throughout the planet. So what can we do? In the rest of the series, I talk to more brilliant people who are trying to figure this out. Next episode, we investigate fossil fuel-based fertilizers and pesticides and ask,
so do we need agrochemicals to feed the world? Obviously, different people are going to have different answers to that question.
This is a bit of a mathematical answer.
Farmers don't do farming. It's the microbes who do farming.
There are growing numbers of studies saying that we actually can produce sufficient calories to feed the world using these other methods.
And onto the credits. This podcast was made possible by IPES-Food, the International Panel of Experts on Sustainable Food Systems, Global Alliance for the Future of Food, and Table. This series was produced by Matthew Kessler, Anna Pascal, and Nicole Pita. Episode was edited by Matthew Kessler. Audio engineering by Adam Titmus. Special thanks to Robbie Blake, Chantel Clement, Jack Thompson, Jackie Turner, Tamsin Blackster, Tara Garnett, Anna LePay. We've received funding from the Rosa Luxemburg Foundation. Cover art was done by the Ethical Agency. Music by Blue Dot Sessions.